In this video, we're going to look at polynomial inequalities, what they are, and how to solve them. As always, let's start with defining what exactly it is that we are going to be talking about. A polynomial inequality is any inequality that can be put in a form f of x is greater than 0, f of x is less than 0, f of x is greater than or equal to 0, or f of x is less than or equal to 0, where f is a polynomial function. In other words, it's any polynomial function that is set not equal to 0. Technically, I could also call the inequality is not equal to, though he is quite rare. Okay, the process for solving polynomial inequalities is as follows. Express the inequality in the form of the polynomial and how it relates to 0. Then solve the equation. Solve it as if it were simply equal to. Those real solutions that we find in that solving of the equation are what we call the boundary points. You need to locate those points on a line, thereby dividing the number line into intervals. Once we have our number line divided into intervals, we're going to select representative numbers from each interval. Those numbers we're going to call test values. And for each test value, we're going to find f of that value. So if the value of that number, if the value of our chosen test value is positive, then every value within that interval will also be positive. On the flip side of that coin, if the value we find is negative, then every value in that interval will also be negative. We're going to use those facts to write the solution set by selecting the intervals or intervals that satisfy the given inequality. This procedure is going to be valid whether we have or equal to or not. So if the inequality involves the or equal to, we'll simply include the boundary points in our solution sets. If it does not have an or equal to, then we simply will not include the boundary points in our solution sets. It's always easier to understand an algorithm if I have an example to look at. So here's a quadratic example, a quadratic inequality. It's already got a 0, so I don't have to worry about that part. So my first step in this case will be to solve it as if it were equal to 0. Since they said minus 2, I'm going to say plus 2 on both sides. Since they squared my x, I'm going to take positive and negative square root. That leaves me with two values, positive square root of 2 and negative square root of 2. And I've got a rather crooked number line here, but that's okay. Our number lines do not have to be precise. They just need to give us an idea of the intervals that the number line is broken into. Now, I've got my two boundary points, and I'm going to draw a line. There is no or equal to, so I'm going to draw a dashed line going up above those 2 points. That lets me know that I have three intervals that I'm interested in, one to the left, one in the center, and one to the right. All right, so I'm going to find f of three different values. Something down here, well, I may not know exactly what the square root of 2 is, but I know it's less than the square root of 4, which is 2. Ooh, my negative didn't show up, did it? All right, so I know negative 2 is down here somewhere. I know 0 is in the middle, and I know positive 2 is on this side. So those are the three values I'm going to choose. F of negative 2 is negative 2 squared minus 2. Negative 2 squared is 4, and 4 minus 2 is 2. So everything down here, every value will be positive. If I try a 0, f of 0 is 0 squared minus 2, which is 0 minus 2, which is negative 2. So every value in this center interval is going to be negative. And when I try f of positive 2, I get 2 squared minus 2, which is again 4 minus 2, which again is 2. That is positive, so everything down here is positive. Now, look to my sign. I want numbers that are greater than 0. That is, I want the positives. Well, the positives are found in two places. Negative infinity up to negative square root 2. And then again, from positive square root of 2 up to positive infinity. And by graph, that would be on a number line with an open parentheses at negative square root of 2. And everything this way shaded. And again, I cannot shade on this thing. Sad. And positive square root of 2 is down here somewhere with 0 in the middle. And he shaded towards positive infinity. So my answer and my graph, well, I can't draw a box around it, but that's it. And one more example for good measure. In the case of this inequality, I do have to find that 0 first. So that's 3x squared plus 13x minus 10 is less than or equal to 0. Okay, so I need to solve it as if it were equal to 0. So 3x squared plus 13x minus 10 equals 0. I need to factor 3x and x are going to have to be my terms. 3 times 10 is 30, so I need factors of 30 with a difference of 13. That would be 15 and 2. So 5 times 3 would give me the 15, and 2 times 1 would give me the 2. I need the 15 to be positive and the 2, therefore, to be negative. And I have my factors. So I set each of these equal to 0, because if you've got two numbers multiplied together to give you 0, one of those two numbers must be 0. It's the zero product property. And since they added 5, I subtract 5. Since they subtracted 2, I add 2. Since they multiplied by 3, I divide by 3. So I have a number line for testing right here. It's going to be my x. I have 0. Somewhere to the right of 0, I have 2/3. Somewhere way a little further off, but it doesn't have to be exact, of 0, I have -5. So this is or equal to, so I'll make my line solid. That's just a visual help to me to remind me to close my boundary in the set. Okay, so I'm going to pick 0 in the middle. I love to pick on 0. He's fast and easy. And here's another guy that's real easy. I'm going to pick 1 on the right. And anything deeper than -5, I'm going to say -6 on the left. Now, I do want to show you another option rather than evaluating f of being f. I could also substitute each of these test points into the original inequality. So I can say 3 times negative 6 squared plus 13 times negative 6 is less than or equal to 10. I don't like doing it this way because I could look at this and tell you whether it's positive or negative, but how it compares to 10, I would actually have to do the math. So that's going to be 3 times 36 minus, because positive times negative, that's 60, 78, is less than or equal to 10. So this is 9108 minus 78, less than or equal to 10. That leaves me 30, less than or equal to 10. If you're going to do it this way, then you got to come back and say that's false. That means he will not be a part of my set. Plugging in 0 and 1 will be much faster, if I can. 3 times 0 squared plus 13 times 0 is less than or equal to 10. Anything times 0 is just 0. So 0 is less than or equal to 10. That's the truth. And then 3 times 1 squared plus 13 times 1 less than or equal to 0. This is 3 plus 13. That would be 16, not 0, 10. Is less than or equal to 10. That is so not true. And since it's not true, this is false. Therefore, the only part I want in my answer is the interval from negative 5 to 2/3. Anything in between those numbers, and because it's or equal to, including those numbers, which again, if I could draw a nice number line, it would be nice, means from negative 5, I would have a bracket that looks like this. At positive 2/3, I'd have another bracket, and I would color everything in between. And that would be my interval and my number line. So whether you want to use the function and evaluate the function for positive and negative and then compare it to the sign, or if you want to substitute into the initial inequality, either way will work and get you to the correct answer.